Okay, I'm going to try to work through a transportation problem. This is from Chapter 7, Section 2. I think it's 1C. So the original tableau is the printed part, and I've written some green, red, and yellow garbage on top that I'll explain in a minute. But the original tableau is the typed part. Remember what this means. These are the sources, these are the destinations. We need to supply the destinations from the sources, and we need to minimize the cost. Now I'm going to try to follow along the steps in the book. The book tells me, first construct an initial solution to the dual problem by defining row values and column values that give me that by using this rule. Okay, so basically what that means is I go back here and I find a minimum value in each row. 7 is the minimum value in the first row. Of course, I'm leaving this off because that's the constant column. 4 is the minimum value in this row. 5 is the minimum value in this row. And then I have these values up here, which give me the residual, right? The 1 is the minimum residual, right? This has residual. 7 plus 1 is 8. This would be 4 plus 5 equals 9, so that's bigger, and 1 plus 4. So 1 is the smallest value here. Same thing here. 7 gives me 3, so that 3 there. 4 to 5 gives me 1. 5 to 8 gives me 3, so 1 is the smallest value there. Then I go here, 4 and 4, so that's a 0. If I go here, I look at 7 to 8 gives me a 1, so 1 is the smallest value here. 7 gives me a 0 here. So that's how I assign the column values based on the row values. Okay, let's move on to the next step. Next step, here it says associate with these a distribution problem. Origins and their supplies and destinations are as follows. You put infinite capacity if the row and column value adds up to the capacity and 0 otherwise. All right, so that's what we have here. So let's see, here we have 7 plus 1 equals 8, so I circled that one. That node is going to have infinite capacity. So I've circled all the ones where they're equal. You can check 4 plus 1 equals 5, 4 plus 0 equals 4, 5 plus 0 equals 5, 7 plus 1 equals 8, 7 plus 0 equals 7. So that's how I've circled all of these values that the row and column sum turns out to work out to be equal. Okay, go back to the procedure. Next it says, try to solve this distribution problem. So I'm using the same tableau, but I'm using distribution problem. I ignore the numbers inside the tableau and just look at the marginal numbers. So let's go back there and see that. All right, so I'm distributing this to here using these nodes here. So I just go ahead and so I'm going to ignore the green values here. I'm just going to use these nodes here, and these all have infinite capacity, so I don't look at the numbers inside the circles. I just assign push as much as I can if there's a circle there. Okay, so let's see how this works. Well, let's do it the usual way. Out of this capacity 8, I can meet all 5 of this here, so I put a 5 there. Okay, and then I have 3 left, so I'll push 3 through here, and that will take care of 3 of these 8 here. Okay, so then I need to get rid of these, take these 6. I have 10 here, so I can push 6 through here, and then I have 4 left, so I can push 4 through here. All right. Right. So then what can so that meets the demand at 5, 6, and 4. Then I get to this row, I have 12, but I can't push that anywhere because these are not open nodes. Okay, so I have a surplus here at 12. Okay, so I'm attempting to solve this distribution problem. Let's see if I can rearrange my flow a little bit to improve it. Okay, so remember how we do this. We do this, the labeling scheme. My surplus is here, and so I have to choose columns according to available capacity, right? So there's available capacity here, so this column is labeled with the row index, with a 3, okay? Now I take this labeled column, and I identify rows according to non-zero flow. Okay, so from this column here, I look for the rows with non-zero flow. That's only this one here. So I label this with a 3. This one actually should not be labeled with a 3 because there's no non-zero flow. Let's see if I can get rid of that. It doesn't really change anything. Okay. All right, so that one has non-zero flow. Now, with this newly labeled row, I need to find columns with non-zero capacity. That's this one and this one, okay? So that comes from row 2, so I label this as row 2. Now, for this newly labeled column, I need to identify rows that have non-zero flow. There's nothing, okay? So I can't label any more rows, so I'm stuck. This means there's no feasible solution for this assignment problem with these open nodes. Okay, so that what that means is I have to go to the next step. Let me go back to the write-up here. And the write-up here says that I need to determine the labeled rows R and C. Okay. Now, once I've determined the labeled rows R and C, you can see what they are here. This counts as labeled also. So I have labeled rows here, labeled columns here. All right. So what does it tell me to do with the labeled rows and columns? Here it says take the minimum of the capacity minus the sum of row and column assignment value. But I take the minimum over the labeled rows and non-labeled columns. Labeled rows and non-labeled columns. Okay, so that's what I've put in yellow here. These are labeled rows and non-labeled columns. So I need to look at what you might call the excess. Okay. So what's the excess here? 4 plus 1 is 5. I have 9, so there's excess of 4. 1 plus 5, 6. I need 10. The excess is 4. Right? 4 plus 1, 5. I have 6 here. The excess is 1. So you can go through and calculate all these excesses here. This is the minimum excess. Okay? So what do I do with that? Well, I'll go back to my instructions. My instructions say that for the rows that are labeled, I add D to the row value. And for the columns that are labeled, I subtract D. Okay, so in this case, I'm looking at the labeled rows and columns. Labeled rows are here, labeled columns are here. So that means I need to add 1 to these two, and I need to subtract 1 from these two. So that's what I've done down here. Okay, new labelings. I've added 1 to the 2 columns that are labeled, the 2 rows that are labeled here, and I subtracted 1 from the 2 columns that are labeled here. Okay? All right, then I start over again. It's nice to start from fresh. I can forget about this stuff and just go through and redo everything. I have my new labelings here. I go ahead and see which ones meet the value inside. 7 plus 1 is 8, so I've circled this. 7 plus 1 is 8 here. 7 plus 0 is 7. So you can see I've circled the values where the row value and the column value equal the capacity value. So I've circled those. Then I go back to my other step that I did before. I change this to an assignment problem where I have infinite capacity at the circled entries. And I go ahead and make assignments the same way, right? From here, I have 8. I can assign 5 to here to fill this one. Then I have 3 left over. I can assign here. I can still put 6 in here from my 10. And then 4, I can put 4 in here. So this red gives me the same assignment I had previously. But let's see if we can improve that. We can use our assignment algorithm to try to improve that. So I go for my surplus. I look where there's non-zero capacity, and that I choose the column there. So that's 3. That's labeled because it comes from 3. Then I go up here to find where there's non-zero flow, which is this. So I have a non-zero flow here. So this is still labeled 3 like before. Then I look for non-zero capacity. Now look what's changed here. That now, because this one is circled, there's non-zero capacity here. So I label both of these as 2. Then when I look for non-zero flow, there's one up here. Okay, so I can label this as 4 because it comes from column 4. And then these two have non-zero capacity, so these are both labeled 1. What that means is that I can improve my solution. I can improve my assignment problem solution. So how can I do that? Well, start from here. This column here where we have non-zero capacity in the last row, in the row with surplus. Now, notice that I have non-zero flow here. I can transfer this flow 4 down to this place, and then that frees up 4 from here, which I can move over here into this node. Okay, so now I have 10 coming out of here, which matches this, and I've increased by 4 the flow, the total flow, and that reduces the surplus to 8. Now, can I reduce it any more? Well, unfortunately, I can't, because this is the only node with non-zero capacity from this source, and I've already satisfied this demand, so I'm done. Now, if I try to label this again, and with this new flow that has a 0 here, I would start by labeling this column 3 because there's non-zero capacity, but there's no more non-zero flow. So if I were to continue, the only labeled columns and rows would be this column and this row. Okay? So if I do the step that's mentioned here with the labeled columns and rows and find the D, I'm going to have to do that just with the column 3 and row 3. And that's what I've done over here. I have to look at these values and look at the excess here. Okay? Now the green labels are my existing labels. Let's look at the excess. 6 plus 1, excess of 3. 6 plus 0, excess of 2. Skip this one. 6 plus 1, excess of 1. 6 plus 0, excess of 2. So the minimum excess is 1. That means I increase this row value by 1, and I need to decrease this labeled column value by 1. Okay. Remember, in this case, we don't need positive values. We can have unrestricted values here. Okay. So my new row and column values are here. So I start over with these row and column values. So what do I do with these values? Well, I find the nodes that are full. I mean, the ones that the row and column value add up to give me the value inside. And you can see that this 7 plus 1 is 8, 7 plus 1 is 8, 7 plus 0 is 7. Notice that I've picked up a new node, which is good. And I also pick up another new node up here, which is good. All right. So I have more nodes, so I have more possibilities when I'm solving the assignment problem. All right. So let's go through, and I can actually use the assignment that I had over here. I can use the same assignment because I only added new nodes, right? So I can redo this, I can reuse this assignment, this brown assignment, which I've done over here. Okay, so the red here is the brown assignment from there. Okay, now can I improve that assignment? Well, let's go through the labeling business again. This still has a surplus, right? And if I do the labeling, now this has non-zero capacity. Okay, so I can label this column also with a 3. Okay, then I have to look at the rows that have non-zero flow. These two have non-zero flow, and it comes from the column 4, so I label these 2 by 4. And then these have non-zero capacity, so I label these by 1. So I can improve my solution. So how do I do that? Well, this demand has already been met. The 4 here has already been met by this 4. So let's look here. Now, I could push an additional 4 through here, and then I wouldn't have to push the 3 from here. Okay, I can move this 3 over here to the 7, so I can meet three of this. So now my surplus is only 4. So let's see if I can do even better from this new flow. So I've duplicated my my tableau down here with the new flow, having a 4 with here and 3 here. So let's do the labeling again. My surplus is here. Non-zero capacity here, so these are both labeled with 3. There's only 0 flow here, so I can't label this row. This has a 4, so I can label this with a 4. Okay. Then this has non-zero capacity, so I can label this with a 2. But then I'm stuck. I can't go any farther. All right. So my labeled rows and columns, here my labeled columns, these 3, 2, 3, 4, my labeled rows are these 2. So I need to look at the unlabeled columns corresponding to the labeled rows and find the minimum excess. Now we should be looking at the crossed out numbers, sorry, because that were the values here. So 5 plus 1 is 6, excess of 3. 7 plus 1 is 8, excess of 2. Then 5 plus 0, this gives me 5, excess of 4, and then 7 plus 0, excess of 1. Okay, so I can increase the rows by 1 and decrease the corresponding columns by 1. And you can see that that's actually going to make this one into a 0, into a node, right? Because this has now become an 8. Okay, so that's going to improve the number of nodes that I have. Okay, number of available capacity. So let's move over here. Now I put the new numbers on the margins here, and then I calculate the excess again. This right, I do these here. This 7 plus 1 is 8. 7 plus 0 is 7. 6 plus minus 1 is 5. Right, so that's all working out okay. I can continue with this flow here. I just put the same flow in there. Okay. Now notice this one went away, but it was already 0 anyway. Okay. Now, but I've opened up another node. Okay, and I can push 4 through this. So now I have no more excess, so I'm finished. So this is my final answer after a very long exodus there. So that's how you do it. Have fun.